Now's your opportunity to kill the 10,000 hours. I mean, I know other people have attempted to, but what does that really boil down to? Is it simply that about 8 hours a day of practice for a dedicated period of time is what leads to rapid plasticity, and that's what was measured? Or is there really some sort of rule about time under seeking clutch state?
The simple answer is, what the study showed was that 10,000 hours was the average amount of time that an expert violinist had spent practicing by the time they reached 20 years old. That's what the study showed. They weren't even experts by that point. That was how much they'd practiced, essentially in their youth. So that number of hours doesn't even translate over to true expertise in violinists in this one specific example. So I don't think there's some fixed number of hours required. It is interesting, other parts of that study kind of looked at the practice routines of these expert violinists. And what they found was that they tended to practice for about 2 sessions of 60 to 90 minutes a day. And I think that's a pretty good rule, right? If you're going to do something hard, you're pushing beyond your current skill level, focusing for 60 to 90 minutes, maybe with, a couple of breaks in there, a couple of times a day, that's probably about as much as most people can do. And I think that also relates to how we perform on a day-to-day basis in other areas of life, right? We kind of expect that we can go to work and we can work really hard for 8 hours straight during the day, but the brain doesn't really work like that. If we're doing hard cognitive work, right, you're focused and highly challenged, as you might be if you're a future virtuoso on the violin and you're trying to really practice and push yourself. You can only really do that for chunks of 20 to 30 minutes, maybe a couple of times of the break, right? So that's why Pomodoro, even though there's no good studies on the Pomodoro technique, those time periods, 25 minutes with a 5-minute break a few times, they do kind of fit into that kind of rhythm. That translates over to multiple areas where we might want to use our brains. And just remember that hard cognitive work and that process of learning can only really happen in those kinds of size of chunks if you want to do them sustainably.
Yeah, before I started writing my book, somebody who's published several very well-received books said you can only write for about 4 solid hours per day, broken up into a couple of sessions.
Yeah.
I was like, come on. I mean, I'm not trying to boast, but I used to go into the lab and sit down and work on a grant for 6 hours or something like that. And I started thinking, was it really 6 hours? Go in there, see my students and postdocs, sit down. Okay, then there was lunch and I walk my dog.
Yeah.
And there were some late nights, but then the next morning I'm kind of dragging because I was in my office really late, and you get real honest with yourself real quick and you go, oh, okay. In the periods of time where I definitely pushed to the 6, 8, 10, 12 hours of just nonstop work as a deadline approached, there was a compensatory drop in output after you click send. And so I think you're right. They're right. It's somewhere between maybe, you're saying 60 to 90 minutes and they're saying 4 hours, but not a whole lot more than that for real focused in clutch state work.
Yeah.
So really digging in and no distractions, no phone, no checking your text messages, just,
Yeah.
Do you ever give yourself forced constraints to get real work done?
Not to force it. I will say that one of the best ways to truly get deep focused work done is to eliminate distractions, right? That's one of the most important things that you can do. So close the email. I would put my phone in a different room or something, because nowadays your own, close Slack. I have Slack, Teams, my lab and I, we interact on, we message back and forth on WhatsApp, there's email. I've got 5 or 6 different ways that people can constantly try and get my attention, right? So eliminating distractions is really important. And again, I return to Gloria Mark's work. She wrote an excellent book called Attention Span, if anybody's really interested in this. But you get used to a pattern of distraction such that when you're not actually being distracted, you will distract yourself, right?
Wow.
But you can be trained out of that as well. But so that thing where you're trying to do work and you reach for your phone for no reason? It's because your brain is kind of used to this pattern of, around about now, somebody will text me or send me an email and I'll reach for my phone. So you go looking for it, even if it hasn't happened. But again, you can train yourself out of that if you have periods where you're not getting constantly distracted. So I will eliminate notifications. But at least for me, what I found is that if I have a ton of friction in terms of trying to get something done, I will usually step away from it because there's something in there that just like needs to click or come back before I can like really engage in it.
Or if you're at a sticking point.
Yeah. Mm-hmm. So if I'm at a sticking point, or it's like if something feels like it's just not coming in the moment, I'll usually switch over to something else, which is also kind of a normal. It's one of a possible set of patterns of work, which is that you have 2 or 3 projects you're working on any given time. If one just like isn't quite working, then you can switch over to the other one and come back to it. And then like the alternative is that when the deadline is so close, and this often happens with a grant deadline, or when I was writing my book, and there's a book deadline, and I've got to get this to my editor in how many days or hours. I tend to just not need to eliminate those things because I'll just focus in. Like I don't feel that kind of draw to be distracted by other things. But that usually only happens for relatively short periods of time, right? It's going to be a day or 2 or hours during a day rather than extended periods of time.
Are you familiar with this recent study about phone on the table, phone in the bag? We would just remind people that if your phone has to be out of the room, even if it's in your bag beneath your chair turned off, you can still focus, but there's a cost. Your cognitive flexibility, et cetera, really suffer. So that means that the brain is unconsciously expecting a call. You're sort of waiting for it. And the way you describe this attentional break expectation thing that we get entrained to interruptions is really interesting. Maybe this is why meditation is such a useful tool for improving focus, is that it's just a forced no breaks thing. Although it's pretty easy to drift in meditation. If you are not used to doing 20 minutes of meditation, you sit down to do that, you set the timer, like your brain can end up way off the trail.
There could be some benefit to that as well, right? Because there's, without kind of building that in, and I don't routinely meditate, but unless you have some part of your day where actually you're not either putting in information, distracting yourself, thinking about a specific thing, right? You don't necessarily get that time to integrate. That's kind of, the classic is you come up with your best ideas in the shower, right? Because that's actually the time when you don't have your phone on you and you're not watching TV and you're not doing all those other things at the same time. So maybe, yes, that's not what meditation is formally for, but it could potentially be beneficial if your mind's going to wander. Making new connections, coming up with new ideas, having that space and time to do it, could potentially be beneficial too.
In these studies, these large-scale trials, what was the diet intervention? Can we distill it down to some things that everyone should do or ought to consider?
Most interventions in the sort of cognitive and psychological space are focused on some version of the Mediterranean diet. There's the MIND diet, Mediterranean intervention to prevent neurodegenerative delay. It came out of the Rush Memory and Aging Project. And it's basically just a version of the Mediterranean diet kind of focused on dementia prevention. And the way they initially created it was they looked at foods that people ate more or less of and created a score, and those who had a higher score had a lower risk of later dementia. It wasn't an intervention when it was first developed, but that was kind of the version. It was kind of a combination of the Mediterranean diet and the DASH diet, which is like a anti-hypertension, blood pressure treatment type diet. So it's seafood, vegetables, berries, whole grains, that kind of stuff.
Not too much saturated fat or animal protein.
Yeah. And so this is very similar to the diet they used in the SMILES trial, which was the first randomized controlled trial in depression that showed significant improvements in mood symptoms. I think the principles are useful, but there's not necessarily a huge amount of evidence to say that like this is the way that you should or you have to eat to maintain cognitive health. There was actually a big trial of the MIND diet. It was published in the New England Journal of Medicine a couple of years ago. And they compared the MIND diet to standard caloric restriction. And actually, they saw similar benefits in both groups. There have been big observational studies that have looked at how much their diet looks like a Mediterranean diet. And those whose diets look more like Mediterranean diets, yes, they have a lower risk of dementia. Of course, right, this is observational data, right? So it's not, you can't say it's causal. But what's interesting in some of these studies, so there was a big one that came out of the UK Biobank, was that they took out individual foods or food components of the Mediterranean diet to see if that changed the relationship between the Mediterranean diet and dementia risk. And there was no food or, olive oil or food group or, eating more or less meat that changed the relationship between the Mediterranean diet and dementia risk. So what that tells me is it's much more about whole foods, they're nutrient dense, rather than avoiding any, you have to consume lots of olive oil, right? Or you have to restrict meat. Because if those things are eaten in the context of all this other stuff, it's really that bigger context of diet quality and nutrient density that really matters. So the parts of diet that I think about are there's three. So there's energy, there's nutrients, and then there's overall dietary pattern. So one of the confounding things about that trial I told you about, the MIND diet versus caloric restriction, is you're like, well, the MIND diet should win out, right? How does caloric restriction do just as well? And in the kind of average population, we tend to have some issues with metabolic health and have been in a state of chronic energy excess for some period of time. There's been some very nice studies that have looked at brain aging and brain volume or brain reserve across different populations. There was one group that looked at different tribes in Bolivia, the Bolivian Chimane, who are a hunter-gatherer group, the Mosetan, who are kind of an intermediate group between the Chimane and like a standard kind of industrialized group, and then industrialized humans in the US and Europe. And what they found is this bell-shaped curve between energy availability and brain volume. And in general, brain volume, right, the more the better, right, we think. And so if you're chronically calorically restricted, your brain is smaller because you just don't have the resources to invest in the structure and to maintain it. At the other end, you see the same thing. So if you're chronically in a chronic state of caloric excess, you also tend to have a smaller brain on average. And this is related to metabolic disease, and potentially what comes with it, higher levels of inflammation, high blood pressure, things like that we know can negatively impact the brain. So the most important thing, and I think this is where some of the benefits of caloric restriction happened in that trial compared to the MIND diet, was that people's cognition improved just because they decrease their energy intake to a point that was, more, was essentially kind of what their brain kind of needed, or, kind of supported their overall physical health, which then affects, cognitive health and brain volume and brain function. So the first thing to do is to make sure that you're eating enough, but not too much, right? And that's very simplistic, but like energy is really critical, energy availability, not too low, not too high. Then the next thing that you need is nutrients. We know there are several critical nutrients related to cognitive function and risk of dementia. The ones that we have the best evidence for are vitamin D, iron, omega-3 fatty acids, the B vitamins involved, and the B vitamins involved in methylation. So particularly B12 and folate, also potentially B6 and riboflavin, although that might depend a little bit more on the individual. Then there are some other nutrients that have some pretty good evidence for them. So many of the antioxidant polyphenols, things that you get from berries, coffee, tea, chocolate, the carotenoids that make things orange, yellow, and red, lutein, zeaxanthin, astaxanthin, if it comes from seafood, that's what makes shrimp and salmon pink. And then, some other aspects like dietary fiber seems to have, some benefits as well.
Not magnesium.
So magnesium is absolutely in there too. And in general, I think, so magnesium, zinc, then there's some of the structural lipid components, things like choline and ethanolamine that you might get from nuts and seeds or eggs. They have some slightly less, less evidence, really when you're looking at brain changes over time and dementia risk, but they certainly do seem to be related to cognitive function. So there are some studies that show that those who have lower magnesium intakes tend on average to perform less well on some cognitive function tests. So all of those do seem to be important.
I have two questions about nutrients and brain health in the short and long term. And they have to do with interactions between nutrients, which, at least to my understanding, are rarely explored. You know, you'll see studies of supplementing omega-3 or having people eat some fatty fish or less and so on, but rarely in the presence or absence of some other vitamin that, you know, that can potentially impact the same pathways. So there's synergy, there's also, you know, necessity. So that could impact results. The other piece is, on what time scale are these nutrients needed and on what time scale are they metabolized? So maybe to just kind of drill into the second question first. So, you know, I'm not out here as like the defender of supplements, but I've been taking supplements in various forms and eating whole foods and eating as generally healthily, you know, less so when I was younger, but still pretty healthy, and more so as I get older. But here's where my brain goes, wait, whole food is great, but let's say dark leafy greens have a bunch of things in them that are fundamentally important for brain and bodily health. Great. And they have fiber, et cetera. How many times a week am I eating dark leafy greens? Let's say I do Monday, Tuesday, Wednesday, I'm great, but then I'm traveling on, you know, Thursday, Friday. Should I be just supplementing Thursday, Friday? Am I good until the next week? I think one of the reasons why eating really well, I think everyone knows what that means, not enough calories, not too many, mostly whole foods, et cetera, enough vegetables, fruits, and high quality protein and quality fats. I think the reason why supplements still become enticing to me, maybe even necessary, is because you can take them every day very easily. So you can make sure that you're in range and maybe above range. So let's take one of these things. Okay, omega-3 fatty acids. I believe that the data are pretty compelling. They can be helpful for health, maybe even brain health. Certainly, I believe that. But let's say the early part of my week is omega-3 rich and the later part of my week is omega-3 poor. Am I good? Versus, you know, spreading it out across the week. It just becomes difficult to eat in a truly healthy way if it's the case that it has to be consistent every 24 hours. So what do we know?
So again, I think we're often tempted to overcomplicate this and try and think, oh, you know, I have to hit all these things at this interval, and if I can't do that, then I have to supplement. And in reality, we probably have more buffer in the system than we realize. So omega-3 fats is a really good example. Your adipose tissue, your fat tissue, is a depot. You know, it kind of stores excess omega-3s. Actually, I wrote a paper on this with a colleague of mine, Rory Heath, a few years ago. The long-chain omega-3s that we have in our fat stores may help to explain why supplementation does or doesn't work in some of these trials, because some people just have more kind of hanging around. And if you eat more than you need on one day, especially in a state of caloric excess, that's going to be stored in your fat tissue, and then when you're sleeping or when you initiate lipolysis, the breakdown of fat, so particularly during periods like you're doing exercise, those then get released and the brain then has access to them. So there's some studies that show that this relates to the form of the omega-3s as well. So many people will tell you that you have to take omega-3s in the phospholipid form, which is like a special supplement. You can get it from krill, and the form is with the fat is attached to like a phospholipid head group, just like it would be if it was sitting in a cell membrane. And there's a specific pathway for those to get into the brain.
It's only krill, or is fish oil also?
No, so fish tends to be the triglyceride form, which is glycerol and then 3 fatty acids attached. When you compare a single dose of phospholipid versus triglyceride form, then more of the phospholipid form gets into the brain. Some of this, most of this comes from rodent studies. But what's interesting is that if you supplement over several days, it all kind of comes out in the wash, because the triglyceride form cycles through the adipose tissue as a depot, and then it gets released and the brain can then use it. So if you're going to take just one day of supplement and you want to get as much of that omega-3 in your brain, yes, you should take you should take the phospholipid form. But the form that comes in seafood, which is primarily the triglyceride form is regulated through the body's fat stores. So this is a really long way of me telling you, if you eat some fish early in the week, you don't then have to supplement later in the week, as long as you kind of enough. And especially if you've consistently eaten seafood across your entire life, because you probably have a bit of a depot. And so what you see in several trials where they've given omega-3s to decrease dementia risk or improve cognitive function, so many studies like that have been done. There was actually a very recent one that just came out of USC where they gave omega-3s for a long period of time. They measured omega-3 levels in the CSF, right, in the spinal fluid of these people, to show that the omega-3s were getting into the brain. They didn't see any changes in terms of cognitive function or brain structure on an MRI scan. So everybody's like, well, omega-3s don't work. But when you kind of squint at the data, and they didn't quite give me the data that I wanted, but when you look at it, the people in the trial just didn't seem that omega-3 deficient in the first place. So, right, if this isn't something that you need more of to start with, giving a load more of it isn't going to make that much of a difference, right? And this is the case for all of these different supplements. So the best advice, if you have access to it, is to test your levels, test your vitamin D levels, test your hemoglobin and iron levels, test your omega-3 levels, test your homocysteine levels, which is as a marker of B vitamin status, which we know is a risk factor for cognitive decline, dementia as well. So if you can test your levels and it shows that you need more, and yes, there are the normal ranges that you have on a blood test are not necessarily the same as the risk ranges. So homocysteine is a good example. A normal range for homocysteine, which goes up if you need some of these methylation-dependent B vitamins, the normal range might go up to like 15 or 16. But we know that risk is definitely elevated above 13 and is probably elevated above sort of 10 to 11. So what your target range really might be is probably lower than what the normal range might be. But we have very good evidence that if you then supplement when somebody is above that range and you bring that down, you see significant improvements in cognitive function or slowed cognitive decline. That is particularly the case for omega-3s and B vitamins that lower homocysteine. And so this is the interactions that you were talking about earlier. And this is the best one that we know of, although I'm sure there are many more. Like I said, there are lots of trials that have given omega-3s or have given B vitamins to lower homocysteine and just haven't seen much of an effect. And everybody goes, oh, well, they don't work. But there are now at least 3 randomized controlled trials that have shown that omega-3 status and B vitamin status interact, and they're dependent on one another. So if you give B vitamins to somebody who has elevated homocysteine, you bring down their homocysteine, but they have poor omega-3 levels, you don't see any benefit. And that's been shown in 2 trials. It was originally shown in the VitaCog trial that was run out of the University of Oxford. It was then replicated in the B-Proof trial. Then the other side has also been shown. There was in the Omega AD trial, they showed that supplementing with omega-3s didn't result in any benefit if people had elevated homocysteine. So that's just one example. And you can imagine, like you kind of said, there are probably lots of these. And if we're not, going into a study actually looking like, well, what nutrients does this person need? And then supplementing with them, you're not going to find any effect. You shouldn't be surprised when there's when the study doesn't show anything. Potentially the one recent example of kind of just giving a broad-based kind of set of nutrients, so with a multivitamin, that seemed to work fairly well was the Cosmos study. People may have heard of. It was thousands of people, of older adults, and they were given either a multivitamin or a flavonoid supplement.
It's like a Centrum type vitamin.
Yeah, right? it was Centrum Silver, like the most basic multivitamin, just 100% of the recommended daily allowance, not like no like massive doses of anything. And in that study, those who got the multivitamin saw, changes in cognitive function that suggested some improvements. But that was literally just covering the bases, right? No massive doses, the most basic multivitamin. So in the kind of general population, I think you could say that something like that is probably a reasonable strategy. Mm-hmm. But what they also showed was that supplementing with this antioxidant cocoflavanol was only beneficial in those who tended to have a poor quality diet to start with, right? So they just weren't getting many of these kind of compounds from their diet. If you're drinking a lot of coffee, eating a lot of berries, eating a lot of fruits and vegetables, you probably don't need it because you're already getting it.